You wake up, you age, and you remember the past, but never the future. It's a curious aspect of life, isn't it? In physics, many laws work the same, whether time moves forward or backward. Take Newton's laws, or even quantum mechanics. They're time reversible. Imagine watching two billiard balls collide and then rewind the footage. You wouldn't know the difference. So, why doesn't our reality reflect this symmetry? Why does a shattered glass remain broken? Why do our memories only flow in one direction? The answer lies in the second law of thermodynamics, the one law that breaks the time reversal rule. The second law states that in a closed system, entropy, or disorder, always increases. Think about it. When you shuffle a deck of cards, it becomes messy. A hot cup of coffee cools down, but never spontaneously heats back up. Ice melts and doesn't refreeze on its own. This increase in entropy gives us a thermodynamic arrow of time, guiding us from order to chaos. Our experiences, memories, causes, and effects align with this direction, reinforcing the idea that time flows forward. But why did the universe begin in such a low entropy state? Right after the Big Bang, the early universe was hot, dense, and surprisingly orderly. As space expanded, entropy began to rise. Stars formed, burned out, and galaxies scattered, all while cosmic expansion provided more room for entropy to grow. This relentless increase in disorder is why time keeps moving forward. Yet, it raises a profound question. What happens when entropy reaches its maximum? This scenario is known as the heat death of the universe. If entropy continues to increase, there will come a time when it can't rise any further. In this state, everything will be evenly spread out. No stars, no structure, no change. And without change, time as we know it ceases to exist. Imagine a cold, quiet universe where nothing happens. No change means no way to differentiate between before and after. It's a timeless void. Now, here's where it gets even stranger. Enter the Boltzmann brain paradox. If the universe is governed by random fluctuations, it's statistically more likely for a single conscious brain to spontaneously pop into existence than for an entire low entropy universe to form. Yet, we experience a consistent reality, not just fleeting moments of awareness. This suggests that the universe indeed began in an ordered state, and time flows forward because that's how entropy unfolds on a cosmic scale. So, if time flows forward, can we ever go back? Time travel to the future is theoretically possible according to relativity. If you move fast enough or get close to a black hole, you age more slowly. But traveling backward? That's a different story. There are hypothetical concepts like wormholes and closed time loops, but they come with their own paradoxes and challenges to causality. Plus, the second law of thermodynamics doesn't favor time moving backward. While science fiction loves to explore these ideas, physics keeps time firmly locked in a forward direction. Time moves forward because the universe started in order and is gradually drifting toward chaos. You age, stars die, and entropy rises. It's not the ticking of a clock that defines the arrow of time. It's the relentless march of disorder that shapes our reality.